finished a quite compact LED flasher using modified Joule Thief circuit. Here there are two inductors close together, they are magnetically coupled, and RC network which makes pulsing. And it is supplied by 4 photodiodes. Starts pulsing at 0.5 volts. Underside is quite straightforward. Of course, it's much brighter after it has seen some sunlight. Here you see coils. It doesn't work with every inductance. With 100 microhenries it works, but not so nice. And this is giving time constant, about 1 second. It flashes in the darkness some 20 times from 470 microfarad capacitor. Next I made one more blinker, but using solar panel from Solar Flower. And it is more efficient compared to photodiodes. But photodiode version looks more professional and it is more compact. Side-to-side comparison of different blinkers. These are with Joule Thief circuit and these are with CMOS circuit. And this is the brightest one. Now nice blinking in the dark. And the compact ones are gone because the coil is not so efficient. 3 other blinkers will run quite long time, from 1000 microfarads, so I will not wait. When inductors are close together, it starts to oscillate. Now it is 1 volt. Now I have flipped in one inductor and it still works. This is somewhat surprising. Works with 330 microhenries, but not with 68. Doesn't work with 200 microhenries. Added is resistor 1 megohm and capacitor 0.1 microfarad. Now I put 1 microfarad capacitor. Amazingly, inductor can be placed far away. That means that coupling happens inside the transistor. Next try with such inductor also works. Now found inductor which is 2 millihenries and the flashes are much brighter. Large inductor is in collector circuit, then it doesn't work. Works also with 2 inductors in parallel. Inductance 330 microhenries. With large Soviet inductor 220 microhenries. 3 millihenries inductor, it works only with more light. 1 millihenry inductor looks good. 1 millihenry in collector, much dimmer. Resistance 10 ohms. Optimal variant 400 microhenries, 2 coils. Capacitor Tantal 400 microfarad. These solar panels did not work in the darkness. They have bad internal resistance. Photodiodes and solar cells about 20 microamps, and one photodiode is the same as 4 in series, and with a lot of light we have 400, 500, 670 microamps, but that's a lot. And when it is ambient room light, it is 1 microamp, which is little. voltage, 4 diodes in series in room light, 1 volt, and with the lamp it is 1.5 volts, 1.67. It should be about 2 volts if it is 0.5 volts per cell. Once bright under the lamp illumination, stabilized conditions, we have 0.6 volts and blinks from room light. With only 2 diodes, 0.5 volts. It blinks but not very nice in room light conditions, but if it is bright illumination, then everything is fine. We get 0.9 volts. Now 2 diodes in series, 2 in parallel, 0.58 volts. Larger photodiodes, 0.5 volts and 4 microamps in ambient conditions. That looks better. At dim room light, best results are 4 diodes in series, 0.64 volts. We use white LED to generate voltage. No, because it has phosphorus and it works with UV, and there is no UV in the room light. Can we use red LED to generate light as a solar panel? We get 0.3 volts. That's a little bit. Room light we get nothing. Being 6 photodiodes in series get 2 volts. Diodes in series 0.64 volts at room light. Works with 100 microhenry inductors.